So the first thing we're going to talk about is what the sum of interior angles of polygons are. So first of all, just to clarify, when I say interior angles, I hope we all know that, for instance, in a triangle, this is an interior angle, this is an interior angle, and this is an interior angle. And so I'm asking what the sum of all of those angles are. Well, we just finished up 2 units on triangles, and we found out, or we should be very familiar with the sum of all of the angles in a triangle to be the measure of 180. Let's look at a quadrilateral. Now, quadrilateral you might know because we have some familiar quadrilaterals like a square and a rectangle. But for any quadrilateral, the angles don't have to be 90 degrees. If we drew something called a diagonal of a polygon is a segment that connects any 2 non-consecutive sides. So if I draw this diagonal right here, so it connects 2 non-consecutive sides, I end up with 2 triangles. We know that the sum of the angles in this triangle is 180, and we know that the sum of all the angles in this triangle is 180, and so we have 2 times 180 in a quadrilateral, which is 360. So all of the angles in any quadrilateral add up to be 360. Let's look at a pentagon. A pentagon has 5 sides. If I drew any diagonal in a pentagon, this would be one diagonal, and this would be another diagonal. I can't draw this because this is not a diagonal because these 2 are consecutive sides, and I can't draw this because those 2 are consecutive sides. So I drew 2 diagonals, and I end up with 3 triangles. And so the sum of each triangle's angles is 180. All the angles in a pentagon add up to 3 times 180, which is 540. And lastly, we have a hexagon. If I draw the diagonals in a hexagon, and I remember a hexagon has 6 sides, I end up with 4 triangles. And 4 times 180, because each triangle has a sum of 180, all the angles in a hexagon add up to be 720. There's a pattern here, and it's a theorem. It's called the Polygon Interior Angle Sum Theorem. I'm going to talk about it in the next slide. The Polygon Interior Angle Sum Theorem says the sum of all the interior angles of an n-sided convex polygon is n minus 2 times 180. And if we think of just the previous slide, when we talked about a triangle, we knew all the angles in a triangle added up to be 180. A triangle has 3 sides, 3 minus 1, 3 minus 2 times 180 is 1 times 180, and of course that works. All the angles add up to be 180. Then I had a quadrilateral. I said all the angles in a quadrilateral add up to be 360. Well, quadrilateral has 4 sides. 4 minus 2 times 180 is 2 times 180, which is 360. So do you see how that works? Even if we go to a pentagon, I said all the angles in a pentagon add up to be 540. So we have 5 minus 2 times 180 is 3 times 180, and that's 540. So let's use this theorem to solve some problems. So the first thing I want to do is find the sum of the measures of the interior angles of a convex 24gon. Okay, so I'm just asking for the sum of all the angles in that convex 24gon. So I use this formula, n minus 2 times 180, plug in 24 for n. So I'm going to do 22 times 180, which is 3,960. So all the angles in this polygon add up to be 3,960. Next kind of problem that you might encounter is a problem like this, where you have to find the measure of each interior angle that we don't know. So I have a quadrilateral. So one thing I need to know is what all the angles in this quadrilateral add up to be. Well, from previous slides, I know that 4 minus 2 times 180 is 2 times 180, which is 360. So all these angles have to add up to be 360. So I do 93 plus 76 plus 14x minus 7. So these are just all the angles measures inside the quadrilateral, plus 11x minus 2. That equals 360. And then I just combine like terms. So I'll do 93 plus 76 minus 7 minus 2. So those are all the integers, 160, and then I'll do 14x plus 11x, which is 25x. And then I'll subtract 160 from 360, so I'll get 200, and then I'll divide 200 by 25, and I get 8. So I asked for the measure of the angles that we don't know. So let me just switch pen color here. I'm going to plug in for the measure of angle L. That's angle L. I'm going to plug in 8 for x. So I get, sort of running out of room here, 14 times 8 is 112, minus 7 is 105. So that's L. And then the measure of angle M is 11x minus 2. Oh, so that's 11 times 8 minus 2, which is 88 minus 2, which is 86. And I'm just going to take this opportunity to check my work, make sure that 86 plus 105 plus 93 plus 76 all do add up to 360. So 93 plus 76 plus 105 plus 86. Just did it on my calculator, and yes, they all add up to be 360. Another kind of problem that you might encounter is a problem like this, where we need to find the measure of each interior angle of a regular pentagon. Remember what regular means. Regular means, or a regular polygon means that it has all congruent angles and congruent sides. So every single angle in a pentagon is going to have the same measure. So first I need to find out what the sum of all of the angles in a pentagon are. Well, pentagon has 5 sides, so I plug in 5 for n. 3, so I have 5 minus 2, which is 3. 3 times 180 is 540. So all the angles in the pentagon add up to be 540. But I'm not done yet. I wanted to know the measure of each angle. So the measure of each angle is going to be 550 divided by 5. So I want to know just what one angle equals. So 540 divided by 5 is 108. So that's my answer, degrees. And the last kind of problem that you're going to encounter on using interior angle sum theorem is a problem like this, where we want to find the measure, or find the number of sides in a regular polygon if the measure of each interior angle is 120. So let's think here. If each angle is 120 degrees, that should equal whatever n minus 2 times 180, remember that's the sum of all the angles, divided by n, the number of angles. That's pretty much what I did here. I have the sum of all the angles, and then I divided the sum of all the angles by the number of sides, and I found out what each angle's measure is. So this is how I'm going to set up the problem. Then I'm going to do some algebra. I'm going to multiply both sides by n. I'm going to distribute the 180. I'm going to go over here. I'm going to subtract 180, so I'm going to get negative 60n equals negative 360. And then I'm going to divide negative 360 by 60, or negative 60, and I get 6. So it's actually a hexagon.